In this module, we'll cover 3 different plugins that are native to Studio One. The Pro EQ, Compressor, and Limiter plugins can be used during the song development process or in the final stages when you're ready to master your composition. These plugins will enable you to refine or sculpt the sound of your composition. First, we'll cover the Pro EQ plugin. EQ stands for Equalization. The process of equalization allows us to sculpt each track's sound so that it will occupy its own space within the audio spectrum that can be detected by the human ear. The goal is to have each instrument or vocal sit in its own space and not compete with each other. In other words, the listener should be able to clearly distinguish one instrument from another without them overlapping. To achieve this goal, equalization is used to balance out the frequencies amongst different instruments and/or vocals on a track. Frequency is the rate at which a vibration, in other words a sound, occurs. As you may already know, each instrument has its own range of octaves, and each note in an octave has a specific frequency. We've included a link to a chart of instrument frequencies in the ebook for this module. Pro EQ can be used to affect loudness or softness levels for 7 frequency bands or frequency ranges, giving you the ability to control the harmonic content of a song. Keep in mind that frequency peaking may or may not be something you need to adjust. It'll ultimately depend upon the sound you're striving for. Pro EQ can be added to any channel except the VCA channel. It can also be added to the main out channel to alter the overall sound of a song. However, you can be more precise by inserting the plugin onto individual channels or an FX or bus channel that multiple channels have been sent to. There are advanced plugins on the market that can automate the process of balancing the frequencies of your composition based upon the genre. Although Pro EQ provides presets that are tailored to specific instruments to help you get started, arriving at a successful outcome is a somewhat manual process where you may need to make adjustments to the presets or work with the default setting to achieve the balance that sounds right to you. To demo how to apply the Pro EQ plugin to a specific channel which corresponds to a specific track in a song, I'll first open a song, open the mixer, and then use the Inserts device rack on the piano channel to add the Pro EQ plugin. We now see the graphic user interface of the Pro EQ plugin. This is the default view before we've selected any type of preset. If I click the drop-down menu where it says Default, I can select Instruments and then choose a piano preset. I'll choose Keys Clear Piano. Now I can experiment with the different controls. The numbers along the bottom edge of the audio spectrum represent single frequencies ranging from 50 Hz to 10 kHz. The numbers to the left represent decibels, which act as units of measurement for audio levels. Pro EQ allows us to boost or cut frequencies from negative 24 decibels to positive 24 decibels. Each colored dot corresponds to a different set of knobs outlined in that same color. The first and last colored dots represent what are called low-cut and high-cut filters. The low-cut or LC filter cuts out what are called infrasonic frequencies, whereas the high-cut or HC filter cuts out what are called ultrasonic frequencies. By having these 2 filters activated, we can cut out any extreme low-end or piercing high-end resonances. The other colored dots represent peaking filters that help identify different frequency bands or frequency ranges. As you can see, the orange dot corresponds to the low-frequency controls. The yellow dot corresponds to low-mid-frequency. The green dot corresponds to mid-frequency. The turquoise dot corresponds to high-mid-frequency. And the blue dot corresponds to high-frequency. To help you determine if adjustments need to be made, the Pro EQ plugin provides 3 different options for spectral analysis, which basically just means 3 different ways to see where frequencies may be too low or too high. First, I'll play the song and switch between the 3 spectrum options. Third octave, FFT curve, which stands for Fast Fourier Transform, and Waterfall. What we're seeing is a representation of the frequencies of all the sounds in the composition. However, the adjustments that I'm getting ready to make will only affect the instrument on the channel where I inserted the plugin, while the other instruments will remain unaffected. I'm going to solo the piano track so we can first focus on that instrument. As you can see, most of the peaking is around the low-mid to mid-frequency range. Now I'm going to unmute the saxophone track. In order to see if these two instruments are competing with each other in the same frequency range, I'm going to use the sidechain option. The blue waveform represents the channel with the Pro EQ plugin, in our case the piano channel, while the pink waveform represents the other channel. Be aware that the spectral analysis always defaults to FFT curve when you have the sidechain button selected. I can see that both instruments are peaking mostly in the low-mid to mid-frequency ranges. Equalization is the act of balancing how these two instruments coexist with each other in the same frequency range. If I wish to boost the loudness of the piano over the sax, I can drag the dot up for a specific range. Or I can let the sax take the lead by softening the piano, in other words, dragging the dot down. You'll notice the gain knob as well as the dB count beneath the knob are changing as I move my mouse. You'll also see the frequency count changing. I can drag the Q knob to affect the Q factor or quality factor. Doing this will narrow or broaden the range of frequencies that will be affected. Don't forget, if you ever make a mistake or simply wish to undo any of your edits, you can press Ctrl-Z repeatedly to undo one edit at a time. Next, we'll discuss dynamic process plugins. Dynamics in general refers to the variation between softness and loudness in a composition for the purpose of evoking or conveying a certain mood. True to its name, a compressor plugin compresses a sound's dynamic range. Dynamic range refers to the difference in a mix's softest and loudest moments over time. The compression process involves boosting the softest parts of a sound while attenuating or reducing the loudest parts of a sound, thereby narrowing the sound's dynamic range. The overall goal is to make your composition sound more unified and balanced. You can insert this plugin onto an individual channel or the main out channel depending upon where it may be needed. Using a compressor will enable you to reduce peak audio signals, which may cause clipping or distortion. You'll then have the option of increasing the gain or volume of your composition without risking distortion. Just as we did with the Pro EQ plugin, We'll start by adding the compressor plugin to one of our channels and selecting a preset that fits our instruments. Now let's go over our options for making adjustments. Generally, the most fundamental settings on the compressor are ratio and threshold. The ratio setting will only affect audio that goes beyond a defined threshold. Any audio below the threshold will not be affected. For example, if the ratio is set to 4:1, this means that a signal that's 4 decibels over the threshold level is going to be compressed until only 1 decibel is left that exceeds the threshold, resulting in 3 decibels of gain reduction. In other words, you will hear 1 decibel for every 4 decibels that exceeds the threshold. The higher the ratio, the stronger the compression. The threshold setting will allow you to set the level where you want compression to start. A lower threshold will compress more of the audio. If you happen to have a guitar that's hovering around -12 decibels, but it intermittently spikes up to -7 decibels, you can set the threshold to -11 decibels in order to have the compressor kick in to keep the guitar from sounding louder than what you want it to. The threshold is the blue dot you see in the middle of the compressor's GUI. The knee control affects compression around the threshold point. When there's a sharp corner at the threshold point, this is considered a hard knee. You can increase the knee setting to soften the knee, which rounds out the corner. Doing this will allow for a softer and more gradual transition from non-compressed audio to compressed audio. Some other fundamental concepts are attack and release. Attack has to do with how long it takes for the compressor to react after an audio signal exceeds the threshold. This is essentially the time it takes for the compressor to go from 0 compression to full compression. Conversely, release has to do with how long it takes for the compressor to go from full compression back to 0 compression. Increasing attack and release times, which are measured in milliseconds, will cause the compressor to react more slowly, just as decreasing attack and release times will cause the compressor to react more quickly. Ultimately, you'll need to experiment with different attack and release times to see what produces the sound you're looking for. Another type of plugin that reduces the dynamic range of an audio signal is a limiter. This tool establishes a ceiling which an audio signal cannot go past. It accomplishes this by strongly compressing the signal, keeping it from passing a defined threshold. In essence, a limiter acts as a compressor that operates at a very high ratio to attenuate the loudest parts of a signal. If your compressor is set at a ratio of 10:1 or higher, it is basically acting as a limiter. However, unlike compressors, a limiter is often referred to as a brick wall because it doesn't allow any sound to surpass the defined threshold, not even 1 decibel. Although you can manually watch out for clipping, in other words distortion, by using the meters on each of your channels, a limiter is not only essential for automating this process, but it also ensures that it can be done with precision. The Studio One limiter will help ensure that audio does not exceed the threshold that you've set. By default, the threshold is set at unity gain, or 0 decibels, because generally a track with audio that exceeds 0 decibels will distort. The easiest approach to using the limiter is to start with a preset and make modifications if needed. For this next example, I'm going to add the limiter plugin to our main out channel. The input control allows you to adjust how much of the sound you want from a track or tracks sent into the limiter. The ceiling control allows you to set the maximum output level that you want to limit. The thresh control determines when limiting begins. When the audio signal or sound drops below the threshold that you've set, the release control allows you to set how long you want it to take before limiting will stop. This control can help smooth out the process to reduce any distortion that the limiter may cause during its process. For this example, the -1 decibel or -3 decibel presets will subtract from whatever is on the main out. Since my main out is set to 0 decibels, if I choose the -1 decibel preset, then I'm setting the threshold and the ceiling to -1 decibel, which means that my output signal cannot cross this limit. The limiter also provides different metering views, such as peak RMS, which stands for peak root mean square, and the K system. Peak and RMS will show you the highest output level and the average of the peaks and lows of the audio signal over time based upon how the ear hears sound. K system settings are based upon how our ears actually hear sound. This system was developed by audio engineer Bob Katz. K settings are K12 for broadcast, K14 for music moderately compressed, and K20 for music with a wide dynamic range, such as classical music. Reduction displays how much gain reduction is being applied by the limiter. When it's all said and done, remember that every composition is different. While there are some general guidelines, there are no hard and fast rules as to which plugin you have to use or when. It will ultimately depend upon the sound you're looking to achieve.